Hello, my name is Peter Ditlevsen. I'm a professor of physics of climate at the Niels Bohr Institute at the University of Copenhagen in Denmark. And I have for many years been involved in understanding rapid climate changes and tipping points in the climate, which are times where climate is changing very rapidly, more rapidly than you should expect. The Gulf Stream, and I actually prefer to talk about the Atlantic Meridional Overturning circulation, which are sort of two sides of almost the same coin, is a current, an ocean current in the Atlantic up along the American coast. And because the Earth is rotating, it makes a right turn across the Atlantic and ends up with warm water near Europe. And that part of the current is driven by westerly winds that sort of blows top water. So it's almost like a river meandering through the ocean. But beneath that, there's a much larger circulation, which is the meridional overturning circulation that in the top kilometer of water slowly moves up water, and that water will, when it cools near Greenland, sink to the bottom of the ocean or to the further down, like 2 or 3 kilometers down. This is called the Greenland pump, and that pumps warm water from the tropics to heat Europe. And you can compare it to the Pacific on the other side of the American continent. There, the Pacific sits without such a current. That means that the northern part of the Pacific, which is Alaska and northern Canada, is much colder than Europe, because in Europe we have the Atlantic Meridional Overturning heating us. The reason that we have the circulation is that heavy water sinks to the bottom. It's driven by buoyancy. And water can be heavy, ocean water can be heavy for two reasons. It can be cold and it can be salty. And cold, salty water is heavier than warm, fresh water, and therefore it sinks to the bottom. And that keeps the circulation going. Now, if this water in the top ocean is freshened by inflow of fresh water, the salt is diluted, and that makes the water lighter. And that means that you could end up in a situation where this circulation is shut off, that it's called the deep water formation, when heavy water sinks to the bottom, that stops. And then we go into what is called the off mode, the situation where there is not such a circulation. So it would end up to be a little more like the Pacific Ocean than the Atlantic as it is now. If this happens, we would, in Europe and actually also in the American East Coast, we will see a different climate from what we have now. Especially in Europe, we'll see a colder climate, because all that heat that's transported via the Atlantic overturning circulation, that's about 25% of all the heat that comes from the tropics and heats the mid-latitude and the polar regions. So that would make for a much colder Europe. Europe could potentially become like Alaska or northern Canada, which is at the same latitude as northern Europe. We predict was that this could happen in the middle of this century, which is around 2050, 60, but with some 30 years on each side as the uncertainty, because climate is difficult to predict accurately. My inspiration was, I'm a trained as a physicist. So I was very much, when I was young, interested in what explains the way our universe looks. What if we see out there galaxies and planets, but also how things work, how things that we invent, and how nature itself worked. I was really much interested in the chaotic nature of making predictions of the weather, understanding nature around us. And for that, I had to study a lot of mathematics, because we really need to understand the equations that are underlying what happens in nature.